So I'm going to talk about mechanical seals and seal water savings that you can achieve in your paper mill. So the mechanical seals are an essential part of all the equipment that you have in your paper mill. So it can be in all the rotating equipment that you have, screens, pumps, agitators, refiners, pulpers, everywhere. From the previous presentation, you could have mechanical seals in those vacuum pumps, those meshes, not in the turbo blowers, but pretty much everywhere else. Anywhere you have a fast-moving shaft, liquid, and pressure, that's where you can find a mechanical seal. So as a starter, it looks like this, and if you work in a paper mill or deliver projects, you can think about how many equipment do you have? How many mechanical seals can you find in this plant of yours? And then we go to a bit of details about the mechanical seals. Mechanical seals are categorized by their function. You can have a single-acting mechanical seal, double-acting mechanical seal, or quench seal. The idea here is that if you have a single-acting mechanical seal, you have one pair of sliding faces, and it's lubricated by the product, so your stock, the fiber suspension. Then you can have a quench seal, which means that you have a bit of a flush in the back of the mechanical seal, which removes the leakage and gives a bit of cooling. That's a bit of a compromise between a single and a double-acting mechanical seal. A double-acting mechanical seal is then where you have two sets of sliding faces and you pressurize it with water. The idea here is then you have absolutely no leakage of the product, and the mechanical seal is lubricated better, so you get a much better performance out of it. Now, during the 2000s, our customers noticed that, okay, if you use a double-acting mechanical seal, the MTBF, the mean time between failure, goes up. So obviously, over the years in the 1990s, we delivered maybe 30% were double-acting mechanical seals, but that grew then to 70% roughly. And the quench seals are pretty much vanishing. So we pushed, as an industry, use double-acting seals, put in water in the seal, you get better lifetime. Lifetime goes up from 3 years to maybe 6 years, 6.5, or something like that. So now most of the seals are double-acting, only condensate seals, pump seals are single, but at the same time, what did we do? We learned you to use more water. We doubled the amount of seal water that you're using in your plant. So you have to somehow control that amount of water that you're using. Of course, engineers invent ways to reduce the water consumption. You can have thermosiphon systems, which are very popular in the chemical industry and oil and gas. Or then, this would be then Plan 52, 53A, and so on. Or then you can have a water line. Now, in a paper mill, you have lots of water everywhere. You have the water lines available. So this was a natural choice that you put Plan 54 water line system to all these mechanical seals. Plan 54 sounds nice, but in essence, you have 2 Sulzer All-Star pumps or hundreds ACPs, small size, and they produce all the water that all these mechanical seals that you have in the plant use. But if you just connect the water line and flush it through the seal, that would be 10, 20 liters per minute. So a company in Finland called Kytölä eventually came up with a flow control device, and now all mechanical seal companies are selling them. Different kinds, but in essence the same. You restrict the flow coming into the seal. You have 2 knobs where you control the flow and the pressure. So the point is, then we'll show you that, okay, you restrict the flow 4 liters per minute, 2 bar higher than what you have in the pump. All good, but there are still 2 problems with this thing. 4 liters a minute, there are very many minutes in a year. So when you add it all up, that's quite a lot of water for one mechanical seal. And we made you double the amount of double-acting seals you had. So it all adds up. And when using these, another problem in my mind is that they are in front of the seal. And we specified that the mechanical seal water has to be very pure. But that is almost never the case. It's taken from the nearest river. It's mechanically cleaned. So it's not chemically cleaned water. It's not potable water. It has dirt in it, organic material. And regardless of whose flow control device you're using, this is in front of the seal and all the dirt gets clogged in this equipment. So you have reduced the water consumption, but when this blocks, the water stops to the seal and it needed it for lubrication and cooling. So now we are breaking the seal, saving water, but at the same time causing problems with this water saving and restriction of the operation. But anyway, this is what we have been doing all the time. We have been telling 2 bars above the process pressure, 4 liters a minute, adjust it, install these kits, and you put them everywhere in your mill. And my personal opinion is that this is perhaps not the best way to do it. So if we take a bit of a story now, the number of mechanical seals or pumps and equipment that you have in your mill, it varies by mill size. But let's say 50 to 200. That's the amount that you typically have in a smaller tissue mill or a larger 2-line carton board mill or whatever. When you add that, all the minutes and 4 liters per minute, it adds up to 2,000 cubic meters per mechanical seal per year. Now when you add that times the amount of equipment you have, the total volume is going to be a tanker. If it's 50, it's going to be a small tanker, 50 times 2,000 cubic meter. If you have 200, the amount of water will fill a super tanker. That's how much water we're talking about. And the next thing is that we tell you have to pressurize it with those pumps to about 6 bar, 10 bar, so that it's always higher than the process pressure you're running in those pumps. And what does that mean? It means you take that tanker and your seal water pumps, lift it all the way up here, up to a height of 60 meters, 70 meters. And after that, you open a valve, adjust it a bit, and all that water runs through the mechanical seals, down on the floor, where it goes to the canal and is collected, goes to the water treatment plant, you clean it up, and then you do it again. And the reason you do it is because 40 years we have been telling you have to do this. So we created a bit of a problem for you. If somebody would come and this would have not been done before, they would say that, are you insane? We are not doing this. But this is what has slowly happened in the mechanical seal industry because the seals need that water. But we want to change this. And right now we want to globally change this idea. We have been trying to change this since 1993, but a bit like in the previous example, we have been working in Finland, testing every application, every mill, what can we do, what can't we do, since 1993. And the key takeaway of this slide is that obviously we are extremely bad at selling because it's 2021 and now we are here. So the product looks like this, and the main message of this whole presentation is that you do not need to use flowing water in mechanical seals in your mill. That is the key point. So here you have basically what the idea is. We have the mechanical seal. It's a non-flow mechanical seal. That's what we call it. It has a technology that it doesn't need cooling. It needs the pressurized water, but it doesn't need cooling, no flow. So you have the water line coming in right here to this system. Then it goes to the mechanical seal, back and out. And the only moving part here is that valve that you use only when you vent. You flush all the air out of it and you close. Done. After that, the mechanical seal doesn't use water. You still need the pumps, you still need a 6 to 8 bar line, but it doesn't use 200,000 cubic meters of water every year. And in addition, now there is no flow that bringing that dirt into the system. So at the same time we did this, we found out something else as a bonus. But I will get back to that. Often when I present this to maintenance managers at mills, that you can save this much water, I get the reaction, so what? 100,000 cubic meters of water, so what? We use 4 million. It doesn't matter. But the fact is that these days all the companies look at how much they use energy, like in the previous presentation, how much they use water, and they're interested in that, and with anything we can use to make it more efficient is interesting. And mechanical seals are a simple thing how to improve this. So even if the initial reaction for maintenance might be, it doesn't matter, but when you add all those together, we're talking about hundreds of thousands of cubic meters of water, and it's easy to change. Just look at the product, think about it, and start implementing it during the regular maintenance or a project. So even if our exports are just starting, we have been looking at export markets for the past 5 years. We have been doing this for a long time in Finland, and right now our sales with non-flow systems are doubling every year. And what's interesting, we have now delivered more than 1,500 systems, but we found out also during these years that the MTBF goes up, because it's easier to maintain a steady pressure than to maintain flow and pressure. So now we found a way to even increase, from a double acting seal to even increase the mean time between failure. So that just came as an added bonus when we started to save seal water. Now the double acting mechanical seal works as long as you're bearing, and that's the target. That's where you save the big money. You also get a lot of water savings, but this is also a key takeaway. And finally, I can show you a couple of references. We have lots of them in Finland, a few of them in the UK, a bit in the Netherlands, countries where there's not too much water, and then also some cases in Italy. But as a starter, we have a tissue mill in Finland. It's interesting because they were the first that started doing this on a bigger scale with us. So that's where much of the testing happened. And these days, when they upgrade, for example, a Valmet Optifiner from packings to mechanical seals, they ask the OEM to put in a non-flow seal immediately. So they will not put in water use, they just get all the benefits and no water use. And now, during the service cycles, they do this all the time. Then we have one company that has given us permission to say their name because this is in their, let's say, DNA. They want to be very, I think, of the circular economy and sustainability. So that's Kotka Mills, that's now part of the MM group. So they had a project where they converted their paper machine to a carton. So there are one paper machine, one carton machine. And during that conversion, they specified non-flow. So we put in 60 units at the same time. Also, they have been adding in the service cycle more and more of the units. So when I made this presentation, they had 93 systems running. So that's 200,000 cubic meters of seal water that they have been saving. So that's already a supertanker amount of water. Then just recently, we have had a customer who has been using our mechanical seal for the past 5 years. And then the maintenance manager said that how can we speed up this water saving? That he wants to have the world's first paper machines that use no seal water at all. So 1st of January, we started a contract. We take care of all their mechanical seals, and we promised that we change between 12 and 15 mechanical seals to non-flow all the time. So right now, they are running 51 units. Every year we put 12 to 15 new ones in. And by the end of 2028, they will have no water consumption for mechanical seals in those 2 paper machines anymore. When that is done, they're going to save 300,000 cubic meters of seal water every year. They will get a better MTBF, and that amount of water is roughly 4% of their complete water consumption. And it was a very simple project for them to do. 1 contract, you take care of it, install Nonflow units, 2,000 cubic meters per seal, end of 2028, no water use left. So, this is the idea. It's called Nonflow. We've been doing it since 1993, but now it's perfect. There are no surprises left. We know everything, every application in pulp and paper. If it's a tissue mill, it's a carton mill, it's a paper mill. We have done all the applications with double-acting seals. If this is interesting for you, you can join us at our stand. EagleBurgmann, stand 52. Happy to tell you more. Thank you very much.
Thank you. Well, maybe you're not a bad seller, but you're a bit in advance. I mean, it's a question of time. And water was not a priority in the past, but for sure it will be in the future. Now, most of our focus is on energy, but for sure water will be the next issue.
Lifting that tanker up is also energy.
Exactly. Okay, thank you. Now we have the last but not least speaker. It's Jorma Järvinen, please. And if I'm not wrong, this technology can be used both in paper making and in converting, isn't it? So this is somehow a bridge between the seminar of today and the one of tomorrow morning. And I already invite you to follow us also tomorrow morning. Please.
Good afternoon, ladies and gentlemen. I do realize that the clock is starting to get close to beer o'clock, so I'll try to be as efficient as possible with this one. The idea here is to talk a little bit about a new dimension of machine vision solutions for tissue and converting. And at ISRA, we have been doing this for 35 years, so we do have quite a lot of experience about this. So we can manufacture machine vision solutions like the web break monitoring, the web inspection system, which will then get you a typical products like parent real defect maps, unwind control systems. You can get customer real defect maps and stack maps and real reports. So literally all the way from the head box to the delivery of the products. And I'll take this bit by bit. So I'll start with the web break monitoring. That's literally process monitoring where you have cameras on your wet end and your press section and maybe a dry end if you happen to have that in your machine. You can get really good image quality with our cameras. I'll talk a little bit about the cameras later, and you will have low maintenance cost on these. The web inspection system is really a quality process control system that gives you really a good view on what your sheet looks like. You have really good cameras, fast cameras, and really a reliable classification of the defects you have. Another thing that you can get from us is that you will get a middle cut inspection in case you're running double width sheets. It'll give you an automatic tracking for your cut positions. You can monitor the cut widths, and you can also see a perfect report of the sheet that you're actually delivering forward in your process. And then you have a paper quality management system that is also a complement to our monitoring and inspection systems that can give you process analytics onwards in the process. If we start with the cameras, our Intellicam cameras are very robust in their view. They are built with a waterproof surrounding. It's really good image quality. We have our illumination built in the cameras, and we also have high definition image cameras in there, so it'll give you a special lens for full scale. You have ultra bright white illumination, so you can get very good pictures of, for instance, this is a trim skirt. You have a system that can handle the worst of the conditions. So there's like, these cameras work up to 110 degrees surrounding, so they can manage most of the surroundings. Another option that we have nowadays is that we can put in an infrared reader in the camera, which can give you the ability to see wet streaks, moisture streaks. So that will give you an extra addition if you happen to have that kind of issues on your machine. If you look at what it can look like, the system, the WIS system looks like, this is like a camera beam with the cameras on top. Then it can detect whatever is in the sheets with the pictures. And if you happen to get a break on your sheet, it immediately sends a signal to the web break monitoring system, and then you get pictures of exactly where was the break originating from. So it can read up every single point of the machine. Typical examples of where you can get these sort of problems is edge cracks, for instance, or if you have holes in the sheets. That's typical what you can see here. Another thing that we have in our system is that if you look at this sheet here, you can see this looks like a giant sheet of mosquito bites. That's literally how sensitive the system can be in the setup, so we do detect everything that goes on the sheet. What we do then is that in algorithms, we take out the most significant things out here, and we can find the repeatability things here. And if you have a repeated error in your sheet, we can start tracking in what position it is, and we can go back and assign that to a specific part of the machine, if it's a foaming fabric, if it's a press felt, or whatever. And I will show you one slide later on where you can actually use this to design design a report for the machine to go and clean that part of the machine automatically later. So we can use the WIS system to run your cleaning sequences if you want to put it in that way. So literally, you can reduce your costs by following your web breaks properly and assigning the reasons for your web breaks, and you can also save money that way because you're minimizing the amount of it. Then when you come to the quality part of it, you can optimize your costs by what we do is every time we make these reports in our web inspection systems, we take out a full role report of every role that we designate. That role report can give you an idea about how good is this role. Can I really ship this to my most sensitive customer, or do I need to design it to something else? In that role report, you can have the edge defect report, you can have the role report, and you can also add information from your own systems if you want to this role report. So you can have like a quality management document out of these measurements. Typically, another thing you look at when it comes to tissue machines is that you really don't want to have critical defects in the tissue reels, because if you think about the next step of it, you go into the converting line, and when you put in 1-ply, 2-ply, 3-ply or 4-ply tissue lines, you need to follow where did you have issues on original roll. So we have the roll report, we have the middle cut reports, and then we have the actual defect logs on every single roll. And then we put those into the report here. We always send the binary data to your converting line. So each and every parent roll can be synchronized. So if we find out that there is, for instance, a weakness in one part of your parent roll, we can give your system a signal stating that now it's a good time to slow down the speed because otherwise you might break. So it automatically can trace this part. So therefore, we can use a system where you reduce the web breaks in converting. This is the linkage between the machine and the converting. Then when it comes to process control, we also have a system where we do these artificial intelligence algorithms. We work with the paper master, which is the name we call it. We have web quality and process analysis here. You can access this globally. It's one platform. You can access this either via your web, if you have a VPN connection, or conventional PCs. You can even put it on a virtual network inside of your own mill in case you have a system where you don't want to have more monitors in your screen. You can put it that way in there. So literally, the inspection technology works this way. You have the acquisition of data through your Intellicams, your web break monitoring, your web inspection systems, your illumination technology. Then you have the artificial intelligence algorithm processing, which puts in the classification. And then we have something we call ePromi models, and this I'm going to come back to because that's the software tool we utilize inside of this. So if you think about the artificial intelligence-based classification, we use deep learning algorithms after the first premium classifier that we put into the system. And the reason why we call it artificial intelligence is that we have by now made sure that all of these systems we have globally have built up a huge library of defects. So we can start with putting all of those into the system initially. So you have an automatic best feature selection to start with. So the only thing your operators needs to do is assign the name of the class of the defect. And you will find different kinds of features on every single defect. These defects are then put into the algorithms, and you can follow onwards what you can do in terms of it. And that's creating also a very fast startup when you start using our systems. The ePromi analytics is production analytics, literally. It improves the process efficiency and product optimization, because what you have literally here is you can get a status quo picture of where are you with our systems that we've implemented, the web break monitoring, the web inspection systems, and then you can add whatever you want from your own process systems into these QMS systems. Gives you the software view on exactly where do you have your status on the head box, the trims, the pickups, wherever you have a camera. So that will give you an optimum balance on how you can follow your own production. Here we go with a specific instrument. When I spoke earlier about these repeating defects, for instance, if you had a repeating defect that turned up in your machine, let's put it this way, in the left edge of the sheet all the time, then what we can do is we can utilize that signal we get from our web inspection system, send it to your operating system of your cleaners, of the felts, of the wires, and then it can guide that this place on the machine needs more cleaning, for instance. This will give you an improved lifetime on your fabrics, on your press felts, and it will also keep the system clean where it needs to be clean. So instead of using the cleaning all over, you can save some water, as we spoke earlier, for instance, by specifying where you put it in. And then, of course, once you've done it, the web inspection system will control that the defect has disappeared. That way, it gives you the indication whether or not it has worked. So, if we take this, I'm just going to go into a quick summary here about things. So, ISRAVision has been focusing on the customer value for the last 35 years, and I just want to say that we're not only working in the paper industry, we can say that we're a global leader when it comes to machine vision, because we also work in the automotive, the plastic, the security, the glass, the non-wovens, etc. Wherever there's a machine vision solution, we have been working with it. We've been working with this for over 35 years when we started the company, and nowadays we have within ISRAVision over 900 employees, and we have 3 manufacturing facilities in Atlanta, in Aachen in Germany, and in Shanghai in China. And to add to this, to show that we are a global player, we were purchased last year by Atlas Copco, so I actually have another 39,000 colleagues nowadays inside of the world. So we are really a global player that can be around, and some of our esteemed customers have allowed us to give some comments on what they experience by working with us. We have more than 10,000 installations in more than 50 countries. So that leaves me with my final slide, how to optimize your bottom line. If you do this right and you have the installations and you follow how you can utilize all the information you get, you can reduce the amount of web breaks, you can improve your quality control by getting specific reports, you can increase the efficiency of your converting lines by getting the reports in there, by using it continuously. It's a very low maintenance system, and doing it all, considering the next generations, it will also contribute in reducing your carbon footprint, which I think is very important in these days. So, with those words, I'd just like to thank you for your attention. And if there's any questions or you have any thoughts about, we will be here at stand 172. We'll be happy to answer any of your questions, and we'll be happy to talk to you about this onwards. Thank you.
Okay. Thank you.